Good morning, everybody. We're going to give people about 1 or 2 more minutes to join, and then we will start. So just hang tight.
Good morning, everyone. This is Tom Haber with Maverick Applied Science. I get to spend the first few minutes with you, at least kind of seeding some questions and priming the pump a little bit and giving you an idea of what we expect from you during this presentation. So first off, thank you very much for attending. I appreciate it. I know it's not always easy to find time in your day to spend on something that doesn't directly impact you, so I hope you get something from this. Again, I appreciate your time. To start out, give an idea of who we are. Repetitious for those of you that have been on all 8 of these with us, but Maverick was founded in 1999 as an independent FRP engineering company. It's always worked to maintain its independence from any fabricators or anything and offer our customers the best knowledge that we can give it regardless of who will build the equipment. Over the last 22 years, we've grown, but maintaining the focus on non-metallic equipment, engineering inspections, and pipe supports that handle those non-metallic equipment best. Jeff Eisenman, you probably all know, the president of Maverick. It's been Maverick for over 30 years. Before that, he was many different things, but I guess he's always been Maverick at heart. Darryl Mikulec is our chief engineer. One of the smartest guys you'll meet. If you ever get the opportunity to sit down with him, just listen. Trust me. And me, I'm no PE. I'm just a regular guy. Just happen to have been blessed to hang around smart people for most of my life. Try to give you an idea of what we're going to do today. Some of the knowledge we're going to try to impart before we get to the questions and answers. First thing I need to do is explain how to ask questions, which is our next slide. From that, we'll hopefully lead off to a few topics I've got in mind that I've seen lately in the industry, and then we'll feed off to your questions. So, how do you ask a question? On the control panel, or whatever it's called on the right-hand side there, is a tab you can click on. It says questions. If you click on that arrow next to the word questions, it'll open up a tab. From there, you can input your question and then send privately. You're welcome to send all, but we're not intending to use names during these questions. We're just going to answer everyone's questions. So hopefully that's easy and it works for everyone. Feel free to submit your questions starting right now if you have one. So a couple of points that I wanted to try to make today while we gather up questions and prepare for that section. If you're not aware of this, there's a significant raw material shortage in the FRP industry right now. Resin is significantly unavailable. And what is available is not always exactly the resin that you would like. There may be a different blend. There was some significant plant shutdowns that happened earlier this year, and the ripple effect of those plant shutdowns is a lack of feedstocks for the raw materials for resin. So on top of the supply chain issues that were already in place because of COVID, and the manpower, honestly, issues that were in place because of COVID, Now as the industry tries to recover and start to rebuild, but when it's out, they're having a hard time finding raw materials. So keep in mind, if you have a project that's active and you're expecting a short delivery of FRP items that you've been promised, you probably want to check with that fabricator again, because sometimes delivery times are being delayed now, and also prices are also being difficult to be held because of the extreme cost pressure from the resin and other raw materials. So if you have a short-term project that you need to get done quickly, you may want to increase your timeline a little bit, because I think your lead times are going to be much longer than you previously expected. Just a little note. Now, pet peeve of mine. When I see purchasing specifications and someone has bought a tank, for instance, or some piping or something, and we ask for the specs so we can do proper inspections and I can find out what your expectations were when you purchased the equipment. So when I start reading through purchasing specifications and they list every FRP standard known to man, English, Spanish, whatever versions you can find, it doesn't always show intelligence on the purchaser's part, because it shows me that you just did a Google search and put every standard out there you can find that said fiberglass. If you do a little bit of work, a little bit of research, you'll find that there's specific specifications that will relate to what you're doing. If you want a filament wound tank, you can't allow specifications to be included that don't include filament winding, that only include contact molding. If you want a vacuum infused head on your tank, well, you can't only include the standards which allow contact molded heads. So take a little bit of time, talk to your subject matter expert, narrow down the list of specifications that you want your project to be built to, and use those. Don't just use every one you can find. Some of the specifications that are still out there in fairly common use are really, really antiquated. And these standards, while they were great in 1969 when they were developed, or in the 90s when they were updated even, things have changed significantly. The fiberglass industry has made leaps and bounds of changes in different types of laminates and things like that, and in specifications and standards that are available. So there's a lot of common standards that are available for you. The ASME RTP1 is a perfect standard for fiberglass tanks that store chemicals, 15 PSI and less. ASTM D3299 is another standard. I believe it's only for atmospheric tanks. Same with 4097, and the others are all specifications that you'll see used in different applications for specific petroleum industries or things like that. But if you want a filament wound tank that's built to a standard, but you put other standards in there that are lesser, then that's what you can get, that's what you can expect. For piping, there's a brand new piping standard out relatively, I think 2019, from ASME that's NPPS and M2. That standard is intended to take the non-metallic portions of B31.1 and B31.3 and combine them into one standard for non-metallic equipment. So right now there is still information in 31.1 and 31.3 on those non-metallic pipings, but NM2 has a significant amount of information on design, supporting, and everything. If you're going to build piping and a piping system, I would highly recommend you look into ASME NPPS NM2 and use it as one of your purchasing standards. The other standards there that are listed go into different types of piping. For instance, if you want centrifugally cast piping, if that's the perfect pipe for your job, but you include the ASTMs and you allow the filament wound piping in your specifications for purchasing, you may not get centrifugally cast piping. So that's why I say limit your specifications to the ones you want. And include specifications for lesser items like flanges. If you want your flanges built in a certain way, maybe you don't want compression molded flanges attached to your pipe. If you put the allowance for compression molded fittings, though, from the ASTM in your purchasing specifications, then you may well get them. So if you only want a contact molded flange that's built out of hand laminates and is a one-piece integral construction, say that and use the proper specification. if you provide the right specifications and you provide the right purchasing guidance, you'll get the equipment that you're expecting. And if you get the equipment you're expecting, you should get the service life out of it that you want. Please take time to review your purchasing specifications or have a third-party non-metallic subject matter expert do it for you. Sometimes it's just a matter of taking the time to do your homework. One other thing that I always enjoy hearing about is testing methods for FRP laminates. There are real great ones, honestly, out there, and it's what I do for a living. I tell you that with disappointment in my voice. But all the things you see listed there are basic tests that you can do, that we commonly do, to find out information on a laminate, whether it's a brand new laminate or a laminate that has been in service. Of all these different test methods, though, there's a couple I want to focus on. I'm not going to go into all of them, I promise, because we do want to do questions and answers. But the first one I show there is visual laminate inspections. To me, this has always been a real simple one. This is a one statement that carries about 5 pages worth of inspections that need to be done. Because the visual inspection of the laminate isn't just to see if there's bubbles in it. It's to see if the same colors of all the laminates match. Did you get light green tank shells and heads and dark brown welds? That's an indication of something that may have been changed. Are the laminates placed right? You know, did they take the laminate and put it centered on the joint? Or is it willy-nilly here, there, and everywhere? Did they actually remember to install the reinforcement pads around the nozzles? Stuff like that. In addition to that, yes, was it dimensionally correct? When I was QA manager, there was always different types of inspectors that came in and inspected our projects. Some just wanted to come in with a tape measure and make sure the nozzles were oriented right in the right place. Some came in and actually checked laminates. And we learned as a fabricator who those inspectors were and who the others weren't. And we would tailor our inspections for them. Because if an inspector was coming in and didn't care about the laminates, there's no sense taking dust off of anything and getting it ready. So you want to make sure that if you do, assuming you do, visual inspections, and eventually you will because the equipment will be on your site and someone will inspect it at that. You want to make sure you do all of the visual inspections, not just make sure that the flanges are located in the right places. That's how you make sure your equipment's going to last a long time. The only other one I really wanted to harp on here is Barco hardness testing. Barco hardness has been something that's been made use of by fabricators and end users for a long time to compare the hardness of the resin in the laminate. As a resin cures and goes from liquid to solid, it gets hard, obviously. And the hardness of that resin has always been measured by Barco hardness. The resin suppliers will provide you an expected Barco hardness reading for a clear casting of one of their laminates in that resin. That should give you the original starting point expectation for your laminate's hardness. There are things that change it, excess nails and graphite and things like that being added into the resin. So if you have a unique laminate, you can contact the resin company and they'll give you the expected hardness of that laminate. But these hardnesses have always been what we use to check initial cure, to make sure that the resin has gone through its full cure, and then as an end user to measure the corrosion of that laminate as it's going down, as the hardness of that laminate is reduced. So it can be very important tools. It's not the only tool that we use, but this is one very important tool. Last point I want to make, and this is a lot of words, and people tell me that they don't like how I present sometimes because I don't read the exact words. But when you have a project that you've spent a year engineering and designing and preparing for, and you have it installed at your site, and there's one last weld that has to be made on the piping system, the tie-in weld, and the contractor that you bought the piping from doesn't do field work. So you just let John Doe, mechanical contractor who's going to install the piping, put it in. That would usually be the first weld that leaks because that contractor doesn't understand the requirements. He wants to do the best job he can, but he's not a non-metallic piping expert or welding expert. If you were going to have someone on your site weld titanium, you would confirm their welding certifications. And I would suggest that if you have someone on your site doing non-metallic welding, you want to confirm their welding certifications too, because this piping is harder to weld than metallic piping is. So you want to know that your installing contractor has experience. There are secondary bonder qualification procedures defined in B31.3 and NM2 and in RTP1 for vessels. So there are ways to show proficiency in making fiberglass welds. Please follow through, do all of the work on your project, and make sure that the final welds are also made by people who are qualified to make those welds. Enough soapbox, I get it. Hey, when you come to my presentation, you get to hear what I want. Thank you again for your time. We are all three married on this stage, but none of us can read minds. So the next goal for us is to try to get your questions and involve you in this process. So, Darryl, I'm done.
All right, just give me a second to switch us over and we'll start the Q&A.
Transfer to our Q&A section of this. Darryl will be the primary speaker here because he's going to offer the questions and probably answer the majority of them, but Jeff doesn't get to. So. Now you'll all get to see how beautiful I am.
Yeah, isn't he though?
In all my glory.
Yeah. I think before we get too far along, I'd like to kind of circle back and talk about Tom's first point was with the resin shortages. And anybody who's out there in industry, I mean, it's just incredible. I mean, literally there are shortages on, it's not just resin or glass, it's across the board. There are shortages of multiple raw materials. And even, you know, this last weekend, I was in Louisiana, and, you know, half the discussion was that there are seas of pickup trucks up in Indiana and Illinois ready to go out to the different dealerships, but they're missing one little chip on the for the onboard control system that is back ordered for months. So there are no trucks anywhere in the U.S. in some cases. And definitely in Louisiana, there was nothing on the lots there. These shortages are pretty broad. They go into a lot of things. We're seeing the effects of the gasoline shortages here recently with the pipeline issue. So if you're a fabricator, if you're an engineer, you have a project coming up, I think the resin shortages and the glass shortages are improving, and I'm told by maybe July, these should sort of get back to normal or at least stabilized where things are starting to flow better. But if you have something coming up this year and you want it built by the end of the year, you need to start getting in gear and get your orders in place now so you can give the manufacturers time to source the material so they can get prepared to work on your project. They're going to need extra time, and having that order in hand makes a big difference to them on where they're focusing their time and where that material is that they're pursuing. So definitely, if you thought you had some time, I would suggest that you expedite your process to start moving along, because they will need more time. So that's really all I wanted to say there.
Okay. Well, welcome everybody. I feel a little bit like Chuck Woolery here. Hopefully we create a match between Tom and Jeff today, see if they're compatible or not. But so now's your chance to ask questions. I have a few here that have come in. It's rare to get the three of us here all at the same time. So now's your chance. There's no question that's too benign or dumb. I mean, if I don't ask it, it either means it's too tough for us to answer, or maybe we don't feel it makes the cut. But no, feel free to ask any questions. You have us here for the next 45 minutes or so. So now's your chance to pick our brains, since we're all here together. So I guess the first question I have, it's piggybacking off of what you're talking about. It's maybe short and sweet, but Jeff, is material shortage in the US or is it worldwide?
No, this is a material shortage that is worldwide. It's everywhere, particularly with respect to resin and glass. But fundamentally, there are some base materials like epoxy, for example, that there is a shortage. There are, everybody may recall the storm that we had in February where we had ice storms that came down all the way into South Texas. That shut down a number of plants in Texas and Louisiana here on the Gulf Coast. We know how to deal with hurricanes and floods, but not so much, freezing and ice storms. So my understanding is some of those plants are just getting back online now from February. To complicate things further, there was a plant in China that had an explosion in a fire that plant produced approximately 25% of the world's epoxy. And the fact that it was providing not just China, but Europe and other areas as well. So you take 25% off the market worldwide, and then you throw in the storm issues that we had here in the U.S. and the entire world, and the U.S., Europe, in Asia, everybody is substantially challenged to find resin right now. There are other raw materials that were challenged by that storm as well. And like I said, they're coming back online. And I think when they come back online, because the plants here don't just supply the U.S., they also supply Europe. But when nothing is coming out of China, they're keeping everything to themselves. So everybody else is kind of in a pinch. So no, it's definitely a worldwide shortage for resin. Like I said, hopefully, I'm told we'll see how it all works out, but maybe by the end of next month, maybe things will start to get back to normal.
Okay. Thanks, Jeff. For those that don't know Jeff, that was his short answer. There are long answers that can, if we don't restrain him well enough. I'll ask a question for Tom here, and it's somebody actually looking for an explanation of kind of the post-cure process. Let's say in the shop, the post-cure process, when would you say it's needed and what is that process like?
Sure. Well, the resin company will usually, if you give them your process, they will give you a resin recommendation that includes whether it should be post-cured or not. A lot of times on a hot service, say you're going to store a chemical above 150 degrees or something, you'll want to make sure that that laminate, that resin is completely cured before you put that hot temperature chemical. So a post-cure is recommended a lot of times in those occasions. There's also times when, for instance, if you use BPO catalyst, you'll probably need a forced cure to complete the operation and ensure that your Barco harnesses come up and you get a good cure of the laminate. Post-cures are done a lot of different ways. The best post-cures are done in ovens where the entire vessel or the entire piece of pipe can be put into an oven and the entire piece of equipment is heated to the recommended temperature and held for the recommended time to ensure that the laminate is fully cured, that all the styrene is driven from the laminate as much as can, and the laminate is fully cross-linked and ready to be in service from day one. You can also see occasions when post-cures are handled with salamanders or propane-type heaters. Those are not the best ways to do it because it's very difficult to maintain good even temperatures throughout the entire piece of equipment. I've seen it done several times, and I've seen multiple thermocouples used on those occasions. It can be done, but there's almost always a hot spot on the backside of wherever the heat is initially introduced. So those are more difficult post-cures. You'll also see people tell you can post-cure things with a heat gun, but unless you're very well calibrated, that is very difficult. So I would recommend an oven, and if you're going to do a vessel or a piping that would require post-cure, I would recommend that you inquire how the post-cure is going to happen up front so that you know what their expectations are. If you can get a good post-cure on the laminate using nothing but a heat gun and the end user agrees to it, I'll inspect it. But you want to know that up front. You want to know their method, how they're planning on doing it up front.
I probably add that Tom kind of pointed to it. When we do post-cure in an oven, generally you want to see thermocouples located in a couple different locations, inside and outside, front and back, depending on what you're looking at. And generally there's a data logger attached where it's basically sampling the temperature once a minute, every 5 minutes, 10 minutes, something like that. And because usually it's over a number of hours, 6 to 8 hours is not uncommon. So you want to have that that automation involved where you can get that assurance that it's reaching temperature and that it's being maintained at that time. And as Tom pointed out, when you get local heat, like with salamanders or something like that, it is more challenged. So at that point, it is important to have kind of continuous monitoring of that process.
Okay, so
Is that too long?
no, so well, a follow up to that would be, it sounds like you guys
That's good.
So it sounds like you guys explained shop post cures pretty well. How would you recommend post cures be done in the field then?
That's extremely difficult. Post-cure to field sometimes also includes an epoxy joint or something like that, or a socket adhesive joint that requires forced heat. Some of those can be done with a heat blanket, kind of a heating pad that gets hot enough. They're very difficult to confirm the heat that's being input into the joint sometimes because everything is underneath the heat blanket, so you can't really, it's hard to put a thermocouple in, it's hard to get a good measurement. I've seen also inside of the tank where it was relined, you can close off all of the blinds and then use a large enough heater and force heat into it, post-cure it in the field that way. But again, it's difficult to get the heat. It takes a bit of a plan to make sure you have enough heat capacity and to make sure you have enough heat entry points to get the heat up to actually post-cure the laminate. So it can be done, it's just not easy. And if you're expecting that on site again, make sure what that plan is before. That's at the end of the job when the contractor is trying to figure out how to do it. There's no easy ways. So you want to know that they have a plan for post-cure if that's going to be a part of the job.
Okay, thanks, Tom. Question for Jeff here. When should I use double veils in the corrosion barrier? What is the benefit?
Well, I guess selecting veils is very specific to the chemical process, and it depends on what the chemistry is, as well as the temperature it's operating at. So double veils, I mean, a lot of processes, like for example, say sulfuric acid processing. We see very, I'll say limited permeability, generally 20 to 30 mils after even 10 to 20 years with the right resin in glass. So you don't need to have a heavy corrosion barrier or double veils necessarily. A standard veil with the right resin and 100 mil corrosion barrier is going to do well with that. Generally, when we look at double veils, it's for more corrosive applications, possibly where we know that we're going to have, higher temperatures. An example of that comes to mind is like HCl, for example. We might want double veils for that if it's operating at, say, over 160 to 180. We might even want to say that we might want like double carbon veil, for example, because there tends to be that tends to work better for that very aggressive service. Additionally, some of the the more base solutions, salts and caustics and things like that, that might be somewhere where we might want to have a base we might want double veil there. But instead of say C veil or carbon veil, we might want a Nexus veil. So it's really specific to the application, and it really bears on what the chemistry is. And generally, we will go through all the details of that, as well as the trace elements, with the tech support from the resin group to make sure that we're in agreement of what the right corrosion barrier construction is in total. Because it's not just the bales, it's what's the thickness of the total corrosion barrier. We may, sometimes 100 mils is fine, sometimes we may want to go to 200 mils. So I think that's something, it's on a case-by-case basis, but really it's when we have more aggressive materials is when we want to have that more resin-rich surface on the interior of that.
Okay, and a follow-up question that I wanted to ask Tom on that is, from a fabricator's perspective or inspector's perspective, what are the drawbacks of double veil?
Well, double veil can be difficult to apply because veils are very thin and it puts a lot of resin on the surface. One of the main reasons for double veil would be to increase your resin at the surface of your laminate, where it's going to be contacting your medium. Whether that's because you want some increased abrasion resistance, or and the abrasion resistance is carried in the resin basically, or you want additional corrosion resistance, you'd use the double veil. But when you try to put double veils down, a lot of times as a fabricator, it's difficult because the layers are very thin, but they're very difficult to saturate. A typical veil layer will hold 90% of its weight in resin. So you have to have a lot of resin on the surface of the mandible. You have to have a lot of resin in, but not too much so that it becomes super saturated and the veil tears because it's very thin material also. So using a double veil corrosion barrier will challenge a fabricator. As far as an inspector, it's not much different. Usually the veils are relatively opaque, relatively clear, and you don't start getting real opaque until you get deeper into the laminate where there's bigger chopped strands. So it will increase the opportunity for air to be entrapped between the veils also. So it takes a lot longer to make a double veil laminate for a good fabricator, but it doesn't impact the inspection much at all.
Okay. We have a question here. I don't know who can best answer, maybe all three of us, but we'll start with Jeff. What about working with international vendors and standards? What kind of challenges do you see with that? Are there any comments you can add to kind of help in these situations?
Well, that's kind of two levels with vendors and then standards. I guess from vendors, anytime you're working on international projects, just like we would here, you want to audit ideally. You want to have some background on that manufacturer. If you can go see them, or you have somebody, plant in Europe, and somebody can go out and look at them, that would be ideal. You want to understand the process. You want to see their quality. You want to see their quality program. Talk to their QC people. Understand their engineering expertise in-house, or if they go out, how does that work? So, we've seen some international projects that work really well. The more remote, it gets more challenging if we're in South America, or if we're in Asia somewhere. You have to look harder to find the same quality of fabrication that we find here in North America. So you have to do more homework, or understand that you're going to have to be on site and doing more inspection in the shops or during installation during the project construction. From a standard standpoint, I guess probably the first thing I would want to say is that so we have North American, we'll say ASME standards and ASTM standards, and then there are generally ISO and EN standards that come out of Europe that we see, and there are very complementary things to them, and there are things that vary greatly, and they're not interchangeable. You can't take a piece of this and a piece of that and blend all these different things into standard. You have to kind of commit to taking one approach or the other, because they don't necessarily equate, they don't necessarily come together, and you'll find gaps if you try to do that. So you really want to pick your standard system that you want to use. But I would say that there are some very good European standards as well. So as long as you define that going in, and the fabricators have familiarity with that, then you should be fine. But you need to kind of choose that up front and identify that so they know what they're getting into.
Yeah, I agree. I think there's good fabricators around the world. I think the only difference, if you are here building something overseas, you may not know that fabricator as well as you might know an American fabricator. If you're in India, you may not know an American fabricator as well as you know the Indian fabricator. So I think what it would do is it would increase your requirements as the end user, as the purchaser, to do your due diligence, to make sure that even though they want to build it to a different standard, that standard is equivalent. A lot of times standards are equivalent in areas, like Jeff said, sometimes they're not. So I think it can be done. There's nothing wrong with going overseas for equipment if you need to, but it puts more onus on you as the project engineer or end user or purchaser to make sure that you're getting what you want. You know, if you order an ASME RTP1 stamped tank, what you're going to get, relatively speaking. If you get the EN version of it, you will probably get the same thing, but maybe you'll have to say, no, you can't use this clause or some part that they do special over there. So I think it can be done. It just takes a little more work on your part as an end user.
More hands-on effort.
Right. You have to be more involved.
Yeah, and be aware of kind of or equals. I mean, obviously, if you're going, you're going to allow a manufacturer from Mexico bid on your project, they're not going to be an RTP1 stamp holder, so your vessel cannot be stamped. But also be aware of them just saying, yeah, well, we can follow RTP1, no problem. Make sure you know they have knowledge of RTP1 and not just the simple design equations. You want to make sure that they're following all the mandatory chapters in RTP1. So just kind of be aware of the or equals, we're equivalent to them. So keep the questions rolling in. We have some more good ones coming up. Again, it can be on anything. It doesn't have to be on Tom's pet peeves, just whatever you want to ask. And we have a question here that I'll answer pretty simply is, why aren't lifting lugs covered in RTP1? And I don't know. That's a great question.
Well, that was an easy.
Yeah.
How come I don't get those?
Yeah, all done. But in all seriousness, so we're all parts of committees. I'm on design subcommittee, Jeff is on fabrication subcommittee, Tom is on materials and quality assurance subcommittee for RTP1. Sometimes when you're involved in these committees, you kind of get bogged down in the details, and you need these outsiders' perspectives to kind of illuminate, where maybe we have some inconsistencies. We say one thing here, one thing there. Or why aren't these things included? It's perfectly logical that lifting lugs should be included. We have hold down lugs. We have, typical constructions for flat bottom, or knuckle transitions. We have a lot of those kind of stock definitions, but we don't have anything for lift lugs. So I think that's a great point. I think that's, when you read these standards and you find these things that seem to be missing, certainly bring them up to people that on the committees, and we bring them up as an agenda item at our meetings, and we'll talk about them and we'll assign them. So that is something that I've thought of in the last year or two of, maybe that is something, or it seems logical to me that lift lugs should certainly be included. There are different methods, and I think maybe that's why it's shied away from when you could have laminated on FRP lift lugs, you could have trunnion style steel lift lugs. So maybe they want to avoid, because there's just different styles, but there certainly could be some kind of generic lift lugs that you could follow. I don't see a reason why we couldn't do that. So that is something I'll bring up in our next agenda for the design subcommittee. Okay, Tom, we have somebody asking about pigmenting. So, we know, I guess, explain the pigmenting, where you might expect to see it, and how that challenges an inspector, and how you can get around that and still confirm that something is well made.
Sure. As an inspector, I hate pigment. As a fabricator, I love pigment. Pigment is necessary for laminates. Pigment helps reflect UV rays. It can protect the inner laminates from the UV rays, things like that. And you want your equipment to all be white if it's this system, or blue if it's that system. So I get it. But if you paint it or pigment it, as an inspector, I have no idea what's inside it. I'll measure it for you, and I'll tell you if it's the right diameter and the right thickness and things like that, but I can't tell you anything about the laminate. So I would request as an inspector that if you're interested in knowing what your laminates look like, save the pigment for the final coat and let me inspect it after the process of fabrication. and then paint it, whatever color you need it to be painted. That lets your inspection still be done and gets it pigmented to whatever color you want it to be, that fits your plant site. But you still know what you've got. And I say this not thinking that any fabricator would ever hide anything. But the manufacturing process is very visual. So a lot of times with laminates, when you're putting them on, you have to see where the air is to move the air. Excellent laminators don't need to see those bubbles move. They know where they are, they know how to push them out. But every laminator is not excellent. So if you want to increase your odds of getting good equipment and honestly be able to do inspections, please don't pigment anything until the end.
Okay, thank you. Let's see here. We have a question. We'll ask Jeff this time. A little ping pong. How does one address a manufacturer's standard FRP pipe joining methods such as socket adhesive or matched taper when a spec calls for something different, such as button wrap?
That's a very good question, actually. So I'm an advocate that, you know, ask for what you want and expect it. And, you know, when I look at most specifications, and specs are getting, you know, better and better all the time, more updated and current. What I mean by that is, you know, a lot of smart people put a lot of time into writing a spec. So, you know, my view is if, you know, you put a lot of thought into it and that this is what you want, you shouldn't deviate. So if there's a reason why you have specified butt joints, unless there's a very good reason why you want to change that after putting all this thought into it, I'm not an advocate of changing. I'd say if I like butt joints because I think they're stronger, or because of the I like the fact that it's a custom pipe and not a commodity pipe, then I'm not going to accept that. If, you know, what I see is sometimes maybe budget comes into play, and, you know, then, you know, it's always a balance between quality, budget, and time schedule. And so when you start to put those other two facets in play, then, you know, as project people, you know, sometimes you're required to find the compromise in the middle ground, and sometimes that will, you know, make you move to considering one of these, say, socket adhesive type of joints. And in that case, I would want to see data on the joint. I'd want to know that, you know, that it's going to be equal to the strength of the pipe, or it's going to meet the pressure requirements of the pipe, that it's been tested, and that it's going to meet the same expectations of the pipe, and do it that way. And then at that point, you want to have qualified laminators to do those joints as well. But that's kind of how I would approach it. And we have had that happen from time to time. Like I said, I prefer to stick with where we put all the thought, but there are compromises that need to be made from time to time. But when you do that, then you have to kind of step back and rethink things to make sure that what you're going to get then is still going to meet your expectations.
Good, thanks. So I have a question here from an owner, and it's something that I've recognized as well, so I want to take some time to talk about it. And it was something that was identifying some issues that they've noticed in ASME NM2, the pressure piping standard that Tom's been talking about. It was first issued in 2018. I think that was the actual date on the document. I think it might have been 2019 when it was actually issued.
Okay.
So that was the first issue. And then there's also ASME NM3 that accompanies that too. There's also NM1 for thermoplastics, but NM2 is FRP. NM3 is, I use it for allowable stresses. There's probably some other things in NM3, but they have generic universal allowable stresses, elastic modulus for type 1, all mat construction, type 2, alternating mat woven roving, and then type 3, 55-degree filament wound. So if you don't do any testing, you can just use these table values. Now, we've noticed when we went through exercises after the 2018 version was published, the maiden copy, that there was a disconnect from when NM2 was created, because they're created separately. So NM2 is a certain faction of people, and M3 is a different group of people. And there were parallel efforts, and they didn't cross over as well. So we identified errors in NM3 that resulted in overly conservative pipe wall thicknesses, particularly for filament wound pipe. We identified that. We basically had an emergency, 11th hour where we had to get something pushed through within we had about a month before the 2020 kind of closed for what was going to be published in 2020. So we got everybody involved that needed to be involved, and we updated the table with values that we thought were reasonable. So it's somewhere in the order of maybe 30% thicker than a similar manufacturer that actually has test data. So keeping in mind, this is just no test data, you're just using these table values. So we want them to be a little bit more conservative. Before it was maybe 100%, 150% thicker. So now we're at about 30%. So I would say get the 2020 version of NM2 and NM3 that is fixed some of the major issues in the tables for the NM3 values. Next, we're currently going through exercises for looking at the type 1 and type 2 and comparing them as well. My first glance is they may be a little bit conservative, but nowhere near where the type 3 for 55-degree filament wound values were way too conservative. So I just wanted to throw that out there for those that have been using the standard, that the 2020 version has been corrected to fix that overly conservative, those overly conservative values of tables. Who am I off here on? Tom? All right, Tom, I'll give you one.
All right.
We have somebody asking how to measure the additive content in corrosion barriers. So maybe first explain maybe additives. And is there a way to confirm after the fact, or does it need to be confirmed before manufacture?
Okay, sure. Yes, this is a difficult one because different additives are used. One of the most common additives would be, say, an abrasive resistant material being added to the resin for abrasion resistance in a pipe or in a tank or something like that. There's really no way to separate back out the abrasion material from the resin once it's been installed. You can do a burnout of the laminate and burn off all the resin. What's left should be the powder, whatever the additive is, and the dust and the glass. You can wash it, maybe remove the glass. I don't know if that works or not, but there's no great way to do it after the fact. The best way to determine whether you got the actual correct count of additive is to do it during the manufacturing, is to be there and watch them. Or see where they've signed off that they added 1 pound of this material to 5 pounds of that material to give you a 20% ratio. If they have that, you can follow the paperwork at least and ensure that it's being done right. I think it would be very difficult to do an after the fact case study to find out. It's possible, maybe that's a good research project in the future. But for now, I know of no good way to find out those percentages. And so again, the best way would be to do it up front.
One thing that, interestingly enough, I'm not sure who asked the question, but we did talk about this issue last week when I was out in the field, and I guess it was sort of postulated that can you make representative laminates and say weight it with say one with 35% silicon carbide, which would be pretty high content, and just make it just like a corrosion barrier, and then weight another one at 25%, and basically have that as your kind of basis for comparison, and basically like shine a light through it and see what kind of light transmits through the laminate, and kind of have that as your ranges. This is the expectation, this is the minimum requirement. We haven't done any testing like that, but something like that might be something to explore. Yeah, it's definitely something that you probably need to do some background work to try to develop your own comparison to come up with some kind of basis of measurement.
Okay. Looks like we have about 10 minutes or so. We have a few last questions here that I want to get to. If I let Jeff go. You might take the whole 10 minutes on this, but how do you know when it's time to replace your tank or pipe? This could be kind of for all of us to sprinkle in, but.
So am I supposed to go with that?
Yes.
Okay.
Wow. In 5 minutes, I'll cut you off.
All
You
right.
get the first one.
Yeah, so, so you have a pipe or tank in process for some period of time. And, you know, as an engineering inspection group, you know, what we want to do is we want to basically give you information so that an informed owner, you know, plant engineer, you can make choices and plan for replacements in due time with time, not as a, you know, an emergency, you know, Chinese fire drill situation. So, you know, ideally you need to basically, it needs to be inspected regularly so you can, because, you know, as Tom pointed, it is visual and it's not linear. So you want to basically develop that time history and look at it after 3 years might be the first one, and then maybe 5 and 7 or 8 and 10, and you know, every 2 or 3 years after that. Most services, somewhere approaching 20 is when you're approaching the end. It's a little less to 30 even, but that's when you really need to start paying attention and looking at it more frequently. So really, you know, when we see that, you know, we're starting to see degradation of corrosion barrier, the bales aren't there. We're seeing, you know, heavy loss of resin in the corrosion barrier. Maybe a lot of glass is getting exposed. We're starting to see the windings underneath. Or we're using Barcos, and where, you know, Barcos are going from 30 brand new to 25, 24, you know, 17, 12, and when we're getting into the single digits is when we're thinking that it's approaching the time to start replacement, and ideally we want to give the owner, usually 24 months is, I think, a good time to get it in the budget and then get it fabricated afterwards. So, you know, that's how we try to approach it, whether it's piping or tanks and vessels. Piping, obviously, you probably want to use bore scope or something like that to see what the interior is looking like. But that's my thoughts.
I think you want to use kind of a risk-based inspection program. I think you want to go through, because each piece of your equipment is going to have a different risk, basically. We've seen just standard emergency water tanks that sit on top of the building that only hold fire water, so there's not corrosive service, it's not pressure service, and those tanks are 40 years old and they still hold water just fine. Probably no need to change that tank, even though it's that old. But you see a sulfuric acid tank that's 5 years old that's got a leak. That should be changed. So there's nothing direct, linear, you know, a tank should last a year, it should last 5 years. I think with a tank or a pipe or anything, you need to base your replacement strategy on your inspections and your requirements of the plant. Maybe that tank is critical to the plant's operation, and if it goes down, the entire plant shuts down. So that gets a more important risk factor than an emergency water tank that's just holding salt water that's left over. So I think it's a multifaceted approach. I think as an employee of a plant or as the system owner or something like that, you should be responsible for knowing your equipment and how important it is to your process. And you should inspect that equipment based on that importance. And you should inspect that equipment based on that importance.
Okay.
Sounds good.
All right. Somebody's asking here kind of generically, but best practices for supporting FRP pipe. I believe that was one of my webinars, I think the second webinar. So just so you guys know, you can go to our website. All of our webinars are there. All same about 45 minutes to an hour, cover a broad range of topics. I think this was one I did, so my feelings are hurt that you haven't watched that webinar, but it is there, and I'll give a kind of a brief rundown of kind of the best practices for supporting FRP pipe. So, I mean, you can't just buy off-the-shelf supports, and sometimes that happens because you forget about the supports until the very end. But important to note, FRP is custom made largely, so built from the ID out, so different pressure ratings, different manufacturers, different construction methods will increase or decrease the thickness of the wall. So the OD is constantly changing. So that's one thing to know why you can't just choose an off-the-shelf support for standard Schedule 40 steel pipe. and use it for FRP, usually what ends up happening is they buy the next size up, and now there's a horrible fit. It's just too large of a gap around, so you don't have good clamping power on the pipe. FRP supports can be wider. We can't point load FRP, non-ductile material. You have to avoid point loads, concentrated loads. You need a nice wide bearing surface. So you're going to see supports for FRP are going to be a good bit wider and more robust than they will be for steel. You're going to have rubber lining on the steel. You don't want steel in direct contact with FRP. The steel will win. And then finally, it has to ensure kind of functionality. So this goes a little bit more into stress analysis, but FRP needs to be analyzed differently than steel does. So we want kind of fixed anchor points in the middle of a run, maybe guide the expansion to the elbows where you have more flexible parts of the system. You need to have intermittent guides, either for wind loading or to restrain thermal expansion and protect fittings, protect nozzles, things like that. So with all that being said, you need a support that matches that functionality that's required from the analysis, whether you need shear collars on the outside of an anchor support, so you clamp in the pipe axially. We don't want to rely just on a friction fit between the clamp and the pipe, so you need shear collars. Maybe you need to weld the support, maybe you need specific gaps at guides or at line stops. So you can analyze the best system in the world, but if you have the wrong supports, or miss the gaps, or forget to weld the support, or forget to put on shear collars, the analysis is invalidated and you're going to have issues with your system. So that's just kind of a quick rundown. But like I said, I think our second webinar does address kind of the importance of pipe supports.
And he said I was going to be long.
It's his only conversation today. He gets what he wants.
All right, let's see. We have time for maybe a couple more here. We will say, Tom, what about dual laminates? Inspection on dual laminates. Methods, criteria, what are you looking for with dual laminates? Maybe explain dual laminates for those who don't.
Sure, yeah. So a dual laminate would be typically a thermoplastic liner, or Teflon or PFA or something like that, with fiberglass on the outside of it to act as a structural cage. The fiberglass would give the structural strength, and the thermoplastic provides enhanced corrosion resistance. There's a lot of different methods because each thermoplastic has a different method for welding and attachment. Dual laminates are extremely difficult, and if you're going to get involved in dual laminates, please use specifications and standards that are proper. And fabricators that are well versed in it, because there's two parts to a dual laminate. There's the liner, which is an entirely separate thermoplastic welding method from fiberglass welding. So just because a fiberglass fabricator knows how to weld fiberglass pipes together, it doesn't mean they know how to perform thermoplastic bonding. So it's important that you make sure that in those cases you use the vendor that understands what you're looking for. Inspections during fabrication of dual laminates are very important. I harp on inspections all the time, and I understand it's because I are one, but you can go back after the fact and reach some of the joints, some of the thermoplastic joints, and spark test them and make sure, assuming there's a carbon target behind them, that each one of those thermoplastic joints is sound. Some joints you can't get to, though. And so those joints you either want to pay special attention to during inspections, or try to minimize them so that they're in a place where you can do some form of inspection. If you can't do that, you just have to go with a good fabricator. Believe in the fabricators. There are outstanding fabricators out there for all different types of dual laminates. We have seen many, many outstanding dual laminate projects produced. So it's not a mystery, it's not a science. You just have to assume that you're going to have some increased inspection points and some increased knowledge that you're going to have to put into yourself to be able to understand what's going on with them.
Okay. Well, I think we're right up to our time here. So we'll kind of wrap this up, and I want to thank everybody for attending. Thank you who have asked questions. They're really good questions, really good discussion. I believe Maverick is the only one kind of doing things like this in terms of interactive Q&A, expert panel, all because of COVID. Soon, hopefully, it's going to be the way we're going to be doing things differently. We're going to get out to touch people, just come and see you guys. So We're probably going to be doing these webinars throughout the end of the year is what we've been talking about. And eventually we're just going to start getting out again, so we don't have to be stuck in here. So if you have any suggestions for topics, if you have suggestions for what to do, basically what we've been doing is Tom's been doing one, I've been doing one, Jeff has been doing one, and then we've been wrapping it up with an expert panel. If you have different suggestions for what you might want to see in any of our specific discussions based on our expertise, or what you'd like to see in place of maybe an expert panel, shoot us a message. We're happy to entertain anything. We don't know what works. We're trying something, as everybody else is in these difficult times. So again, I appreciate you attending. Tom, would you like a shameless plug for your next webinar?
Sure, yes, since I get to do the next one. The next one I'm planning right now, unless one of you comes up with a brilliant idea that I need to do instead, is a comparison of a couple of standards that we use for tanks, ASTM D3299 and RTP1, and try to give a couple of pros and cons for each one, where their strengths and weaknesses lie for each part. I'll try to include some of the international standards, but in my defense, I'm not as strong as them, and I don't want to give false impressions. So, do what I can anyway. We're going to try to do that one on July 13th. So that's about a month and a half from now. Again, another Tuesday at 10 a.m. So hopefully you can all attend that one too.
All right, that sounds great. I'll look forward to that.
I'm sure you will. You won't have to speak.
Yeah. Again, we enjoy doing these and appreciate the interaction. We've had some good questions today. And so we really appreciate everybody who has participated and attended. And we're going to keep this up through the year is our expectation. And then hopefully next year, we're hoping to start planning a new forum in 2022. So hopefully things will get back to normal by then. So, in time, keep an eye out for that. But for now, you can expect about once a month, we're going to continue these. So again, thanks for attending, and we'll see you in a month or so.